Algebra 1, Chapter 6 Test, Part 1 Review. Let's go over our study guide. Problem 1 says match the equation with its graph. This equation is given to me in standard form. When they give you the equation in standard form, the simplest way to find the graph that matches it is to find the x and y intercepts. So we're going to find the x-intercept. And remember, to find the x-intercept, I'm going to let y equal 0. So it's negative 2x minus 6 times 0 equals 12. So negative 2x is equal to 12. Divide by negative 2, x is negative 6. So negative 6, 0, that is my x-intercept. I also need to find the y-intercept. I'm going to do that by letting x equal 0. So I have negative 2 times 0 minus 6y is equal to 12. Negative 6y equals 12. Divide by negative 6, y is negative 2. 0, negative 2 is my y-intercept. So I'm looking for a line that will cross the y-axis at negative 2. The first one does that. The second one here, it also does that. Answer choice C does not, and neither does answer choice D. So I can already eliminate those. Now I need to find out which one of those crosses the x-axis at negative 6. The first one does. The second one crosses at positive 6. So the answer to the first question is A. Question number 2. The rate of change is constant in each table. Find the rate of change. Explain what the rate of change means for the situation. Well, the rate of change would be the change in the x value over the change in the y value, or the change in the y over the x, It's the change in the dependent over the change in the independent. Change in y over the change in x. So I'm going to see how this changes from 240 to 360. This goes up 120. From 360 to 480, it increases by 120. And again, from 480 to 600, it increases by 120. I want to know what's happening on the x values. From 4 to 6, it's increasing by 2. From 6 to 8, it's increasing by 2. And from 8 to 10, it's increasing by 2. So each ratio is the same. That's what makes it be a constant rate of change. And I need to simplify that. That would be 60 over 1. 60 miles over 1 hour. So that is your rate of change, 60 miles per hour. Number 3 asks you to find the rate of change, and it's a graph. So you have to see what's happening here. When they give you a graph, it's probably easier for you to think about finding the vertical change over the horizontal change. It's still the change in y over the change in x. So we'll start here at 0, 0, and we'll find another good intersecting point. What about right here? And be careful on these tables that you pay attention to what you're talking about over here. Pay attention to your scale, because they're not always 1 and 1. For instance, the bottom here is 10 and the side is half, but this is actually in thousands of feet. So what has happened here is we've gone from 0 to 1, so that's actually 1,000 feet, and that happened over a period of 20 seconds. So that's my rate of change. What I need to do now is I need to simplify that, and that simplifies to 50 feet in 1 second. So the balloon rises 50 feet in 1 second. Number 4. You run 6 miles in 1 hour and 18 miles in 3 hours. Find the rate of change. Well, we have time and we have miles. 1 hour, you've gone 6. 3 hours, you've gone 18. To find the rate of change, we want to know how the miles are changing. From 6 to 18, you increased by 12. From 1 to 3, you increased by 2. So you had an increase of 12 miles in 2 hours, which simplifies to 6 miles per hour. Question 5. A chef cooks 9 pounds of chicken for 36 people and 17 pounds of chicken for 68 people. Find the rate of change. Well, we have people and we have pounds. For 36 people, it's 9 pounds. For 68 people, it was 17 pounds. So we want to know what the increase was from 17 to 9, increase of 8 pounds, and the increase in people from 36 to 68 was 32. So our rate was 8 pounds for 32 people. Now when we simplify that, we'll simplify that to 1 pound for 4 people. Then we may want to go one step further and say, well, how much for just one person? That would be 1/4 of a pound per person. Number 6 asks us to find the slope of the line. When you find the slope of a line and you're given a graph, you need to pick out 2 good intersecting corners. There's probably more than 2 good intersecting corners in this graph. Any 2 will do. The first one that catches my eye is here, and the second one is here. And remember that slope is the vertical change over the horizontal change. So we're always going to work from left to right. You're going to read this graph just like you read a book, from left to right. You're going to go down 1 and over 3. So the slope of that line is -1/3. Number 7 asks us to do the same thing. Find the slope. I see this point, and I'm going to go out here and choose this point. Remember, it's rise over run, so I'm going to go up 2 and over 6. 2 over 6. 2 over 6 will simplify to 1/3. It doesn't matter which 2 points you choose, you should always get the same slope. If you had chosen this point, you went up 1 over 3, you would have gotten the same slope. Now I want you to compare these. I want you to notice that a negative slope, like we have in number 6, goes down from left to right, and that a positive slope, like we have in number 7, goes up from left to right. Just remember that. Make note of it. Slope is rise over run. It's also the vertical change over the horizontal change. Well, sometimes they don't give you a graph. Sometimes what they give you are 2 points, and you have to use the slope formula. And the slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So that's what we need to do on number 8. We're going to have to use this slope formula. And for problem number 8, the points are 3, 6 and 10, 3. It's very important that you label these points. This is x sub 1 and y sub 1, and this is x sub 2 and y sub 2. Those subscripts are simply labels. They tell me that it's the first x and the first y, and then they tell me it's the second x and the second y. Now be careful as you plug these into your formula. You need y sub 2, which is 3, minus, that comes right from the formula, y sub 1, which is 6. Then you need x sub 2, which is 10, minus 3. Do your subtraction. 3 minus 6 is negative 3. 10 minus 3 is 7. So the slope here is negative 3 over 7. The negative can be in the top, it can be out front, it can be in the bottom. I tend to put it in the top of the fraction when I work these problems. Number 9 is worked the same way. It's negative 9.7, negative 3.3, x sub 1, y sub 1, and negative 6.7, 11.7, that's x sub 2, y sub 2. You plug it into the same formula. Again, we're using this formula, so I'm going to start with y sub 2, which is 11.7, minus, straight from the formula, y sub 1, which is negative 3.3, over x sub 2, which is negative 6.7, minus x sub 1, which is negative 9.7. Now you need to be careful with your integer rules. You know that this is actually going to turn into addition, and when we add 11.7 and 3.3, we get 15. This also turns into an addition problem. This is negative 6.7 plus 9.7. It's 3. So the slope here, you need to simplify that fraction, is 5 over 1, and you can just write it as 5. Number 10 says a student finds the slope of the line between 18.8 and 13.13, and she writes it this way. What mistake did she make? Well, in order for us to figure out what mistake they made, we need to actually work that problem. So this is our x sub 1 and this is our y sub 1. This is our x sub 2, this is our y sub 2. And we'll need to plug those in. So it needs to be 13 minus 8 over 13 minus 18. So comparing our work to her work, we see that she did not keep the order of the points the same in the numerator and the denominator. And as long as you can explain that to me, I'll give you credit for that. What mistake did she make? She did not keep the order the same in the numerator. Number 11 asks us to find the slope, and it says state whether it's 0 or undefined. So we have a hint here that we're going to have some special cases. We're going to find the slope just like we would any other time. We're going to pick out 2 good points, and we're going to calculate the vertical change over the horizontal change, or the rise over the run. From point here to here, well, how much do I rise? 0. How much do I run? 2. So my slope is 0 over 2. Well, it's perfectly okay to take 0 and divide it by 2. When you do that, you get 0 for an answer. I want you to write horizontal has 0 slope. We're going to work number 12 the same way. We're going to pick out 2 good points, and we're going to count the rise over the run. So from this point to this point, I had a rise of 1, but I had a run of 0. Well, it's okay to do 0 divided by 2, but it's not okay to do 1 divided by 0. This is undefined. So vertical has undefined slope. Number 13. Use the graph. Which plant was the tallest at the beginning? That's asking you to compare the y-intercepts. Well, there's your one, there's the next one, and there's the next one. This is plant 1, plant 2. Plant 1 is solid. Plant 2 is dashed 3 is larger dashes. The one that looks to be the tallest at the beginning was plant 1. It had a y-intercept of 3. Which plant had the greatest rate of change over the 6 weeks? Well, we need to find the slopes. Plant 1 went from 3 to 6, so it went up 3 in a matter of 1 week, 2 weeks, 3 weeks, 4 weeks. That's the slope. Plant 2, which is this dotted line, looks like it's a good corner here and here. It looks like it went up 1 inch in 2 weeks. And plant 3 looks like it went up 1 inch in 1 week. So plant 3 had the greatest rate of change. Find the slope and the y-intercept of the line. Number 14 says y equals 6 over 5x minus 1. Well, remember, y equals mx plus b. M is your slope. B is your y-intercept. So for 14, m is 6 over 5, and b is negative 1. Now, number 15, a little bit different story. They ask us there to find it, and this is what they give me. This is 15. It says 16x plus 2y is negative 34. You can't determine the slope and the y-intercept until you solve for y. So you need to subtract 16x from each side. So we have 2y equals negative 16x minus 34. Again, we're trying to get y isolated, so divide everything by 2. Y equals negative 8x minus 17. So in that case, m is negative 8. I'll move that so you can see it. M is negative 8, and b is negative 17. 16 asks you to write an equation with the given slope and y-intercept. All you do is plug these in. M goes in the first box, B in the second box. That's all you do. Those are just that easy. Number 18, write the slope-intercept form of the equation of the line. Well, you're going to have to determine M and B from the actual graph. The easiest thing for us to determine is probably B, because it's where it crosses the y-axis. Happens right here. We're going to estimate that to be negative 1/2. Now we also need to calculate the slope. We'll use the 2 points that they had picked out, and we'll calculate the rise over the run, checking to see that these axes are counted off in ones. They are. So I'm going up 1, 2, 3, and over 1, 2, 3, 4. So you just plug these in. 3/4 x minus 1/2. Number 19, again, you need to determine M and B. B is negative 1. On this problem, I'm going to have 1, 2, 3, 4, 5, 6, down 6 over 3, which is negative 2. So y equals negative 2x plus negative 1. Number 20 says use the slope and the y-intercept to graph the equation. So you're going to have to graph this one on your own. So you're going to need graph paper. We're going to start at the y-intercept, which is -4, so I'm going to put a dot at -4. From the y-intercept, you're going to apply the slope. The slope's kind of like driving directions. It tells me it's 1/3, so it tells me to go up 1 and over 3. So that's the answer for number 20. Number 21 says, pay $2.10 in advance on your account at the athletic club. Every time she uses the club, $15 is deducted. The situation can be modeled by this equation. Graph the equation, find the account balance after 4 weeks. Well, this is not going to be graphed on something that starts out with 1, 2, 3. These numbers are really large. So we're going to graph this. And we're going to call this the weeks, or the visits, sorry, visits. And on the side, we're going to have the balance. We're going to start with 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how much money did we start with? Started with $210. So every line needs to represent, oh, I don't know, how about 40? So she's going to start right here at the beginning. Each time she visits, it's going to go down $15. Well, $210 is what's in her account. That's her balance. And these are the number of visits. After one visit, it's going to go down $15. So she's going to have $195. After 2 visits, it's going to go down another $15. She's going to have $180. After 3 visits, $165. And after 4 visits, $150. Let's plot these on our graph. We know exactly where 2 and 180 would be right there. 1 and 195 is going to be about right here. 3 and 165. 4 and 150. There's my graph. This is the answer to my question, $150. Number 22 says to find the x and the y intercepts of the line. So number 22, -4x plus 5y is 100. Remember, to find the x-intercept, let y equal 0. So -4x plus 5 times 0 is 100. -4x is 100. Divide, x is -25. The y-intercept, you need to, sorry that you couldn't see that, I'm going to do better. You need to let x equal 0. -4 times 0 plus 5y is 100. So we actually have 5y is 100. Divide by 5, y is 20. Number 23. Number 23, we have 2x plus 3y is -18. Again, to find the x-intercept, I'm going to let y equal 0. So that's going to be 2x plus 3 times 0 is -18. 2x is -18. Divide by 2, x is -9. Technically, we probably should write that as an ordered pair, -9, 0. So this one should be -25, 0. The y-intercept, we need to let x equal 0. So it's going to be 2 times 0 plus 3y is -18. 3y is -18. Divide by 3, y is -6. So 0, -6. This one should have been 0, 20. 24. Question number 24 says, write y equals 2/5 x plus 8 in standard form. Remember, standard form doesn't have any fractions. It's in the form of ax plus by equals c. So the first thing I'm going to do is get rid of the fractions. So I'm going to multiply each part by 5. So I have 5y is equal to, 5 times 2 would be 10, and 10 over 5 would be 2, or 5 goes into 5 once, 5 goes into 5 once. Either way, we're going to get 2x plus 40. Now we're not quite there, almost. We need the x part to be at the beginning. So it doesn't need to be on this side, it needs to be moved over. So I'm going to subtract 2x from each side. Negative 2x plus 5y is equal to 40. This is my answer for number 24. 25. The grocery store sells kumquats for $4 a pound and Asian pears for $3.75. Write an equation in standard form for the weights of the fruit a customer could buy with $12. Well, it's $4 times however many kumquats you purchase plus $3.75 for the number of pears. Together, these two amounts of money need to equal $12. This concludes our study guide for Chapter 6, Part 1.